Hello everyone, this is Dr. Dax. Welcome back to class. We're in week 8. I hope everybody out there is doing well and that everybody is healthy, safe, and that you guys had a great weekend and ready to get started with this week. So in this week's work, we're going to start off by talking about some descriptive analytics in terms of data visualization, business intelligence, and we're really interested in what I call the grammar of graphics. And so in descriptive analytics, and by extension web analytics, we're really talking about one of the core components of any analysis in the life cycle pertaining to a data science project or any specific project. Data aggregation, summarization, and visualization are some of the main pillars supporting this area of data analysis. And since the days of traditional business intelligence, and even in this age when we discuss artificial intelligence, data visualization has been a powerful tool and has been widely adopted by organizations, owing its effectiveness to the ability to abstract in the right information and understanding and interpreting the results clearly and easily. However, dealing with multidimensional data sets can be challenging, and typically if we're dealing with 2 or more attributes, it can start to cause problems since the medium of data analysis and communications is typically restricted to 2 dimensions. So we've got some good information on effective data visualization, and we've spoken about some of the information that in our class. Today we're going to talk about some good ways to deal with structured and unstructured data. So what we'll deal with is some of the following aspects: the grammar of graphics, the effectiveness of dealing with multidimensional structured data ranging from 1 dimension up to several, and we'll talk about a brief intro into visualizing unstructured data. But let's go ahead and get into our presentation and talk about our objectives before we get ahead of ourselves. What we want to accomplish. We want to review the importance of data visualization. I want to be able to define the grammar of graphics, explain summary statistics and how useful this is, observe the major components of the grammar of graphics. And so let's take a look at this. Data visualization and storytelling have always been an important phase of any data science pipeline, involving extracting meaningful insights from data, regardless of the complexity of the data or the project. So take a look at this image here. It's called the Datasaurus dozen. Basically, it's 12 different data sets that are depicted in the same figure. So can you guess what is common among these very different looking sets of data? Basically, what we find is that the summary statistics are the same. If you look at this, it's a fun variant of what is well known as the Anscombe's quartet, which you might be familiar with like this. The key takeaway from the demonstration would be basically don't trust your data blindly and start modeling your own data. Summary statistics can be very deceptive, so always visualize and understand your data attributes before moving on to feature engineering and building statistical, machine learning, and deep learning models. Another important source of motivation, particularly for effective data visualization, can be derived from some really good case studies. So let's take a look at some of those. They even date back several centuries before we even had computers, or are. In one case study that I'd like to share with students, there was a guy named John Snow, and he was famous for visualizing the Broad Street cholera outbreak in London back in 1854. He basically took data and gathered the data around the Broad Street in Center Westminster, London, England, and tracked information unknown to people about what was causing over 600 deaths. And he was a physician, and when he tracked the information, he learned that the commonality was everybody had access to the same public water pump. And he used a dot map to illustrate the cluster of cholera cases around the pump. And he used statistics to illustrate the connection between the quality of the water and the cholera cases. So that was an early example of using statistics. And there are lots of others that we could share. We spend a lot of time on, but what we'll do is I want to give a little bit of a refresher on visualization. I'm assuming that the average person knows about the essential graphs and charts which are used for plotting and visualizing data. So we won't go into detailed explanations, but I'm going to be covering a little bit here, and hopefully it'll help you out. So data visualization should be leveraged on top of data to communicate patterns and insights with clarity, precision, and efficiency, as mentioned by notable visualization pioneer statistician Edward Tufte. So what we can do is we could actually use Python learning ecosystems to recommend different frameworks for visualization. If you use Python, I would recommend that you use Pandas, Matplotlib, Seaborn, Plotly, and Bokeh. And that would be a good starter. And if you're interested in learning more, shoot me a message. But let's talk about understanding the grammar of graphics. To understand what I call the grammar of graphics, you need to understand what we mean by grammar. Grammar is basically defined as a set of structural rules which helps to establish the components of a language. The whole system and structure of a language usually consists of syntax and semantics. So basically, a grammar of graphics is a framework which follows a layered approach to describe and construct visualizations for graphics in a structured manner. A visualization involving multidimensional data often has multiple components or aspects, and leveraging this layered grammar of graphics helps us to understand and describe each component involved in visualization in terms of data, aesthetics, scale, objects, and so on. The original concept of the grammar of graphics was proposed by a guy named Leland Wilkinson, and it covers major aspects pertaining to effective data visualization in greater detail. I would definitely recommend that students check his work out if you ever get the opportunity. It's called The Grammar of Graphics. It's from Springer Publishing. It's a really good book. Anyway, we'll be using a variant of this known as the Layered Grammar of Graphics Framework, which was proposed by Hadley Wickham. He's a reputed data scientist and the creator of the famous R visualization package, ggplot2. And let's take a look at the 7 layers. The major components of the grammar of graphics begins with the data. It's basically, we're starting with the pyramid architecture to show inherent layered hierarchy of components. With one or more dimensions, you can use the components like this. You can start with the data. Always start with the data and identify the dimensions that you want to visualize. Then on top of that, after the data, then we're concerned with the aesthetics. Now, with the aesthetics, what we'll do is confirm the axes based on the data dimensions, the positions of various data points on the plot. Also, you can check if any form of encoding is needed to include size, shape, color, and so on, which are useful in plotting data dimensions. Next, we talk about the scale. Now, in the scale, you want to know, are we going to be representing potential values that vary? Are we using a specific scale to represent multiple values? Are we using a range? We need to know. Then we consider geometric objects, popularly known as geomes. This would cover the way that we would depict the data points in the visualization. So we're going to be using a line bar, scatter plots, line charts. What are we going to do? Once we have that, you can move on to the statistics. Now, in the statistics, we're interested in showing the measures, the summaries that we're visualizing. Are we interested in the central tendency, the spread, confidence intervals, and so on? And once we've gotten that far, you can look at the different facets of the design. What is it composed of? Do we need to create subplots to further explain anything based on the specific data dimensions? How complex is it? Once we have that in place, we can identify the coordinate system. What kind of coordinate system should the visualization be based upon? Should it be a Cartesian? Should it be polar? Is it going to be absolute? We need to know. And so what we'll do is we'll be looking at how to leverage this layered framework and build an effective data visualization for multidimensional data with a hands-on example. So what I want to do is shift gears just a little bit, and we will take a look at Python in a package called Spider. And I've downloaded a widely known data set on wine quality, and it's freely available in the Jupyter package. You can get it off of repositories. I'm going to send it to you in the link in case you want to take a look at it yourself, but I'll show you what we did here. What I did was I went to the repository from the link and downloaded the data set and just worked with it locally. But you can also port it in, working with some libraries it's built into, but I find it easier just to work with the data locally. So anyway, I'm going to go ahead and open up that information. I'm going to go to our notes. It's a lot of code, so I've got it pre-written, and I'm just going to copy sections of code and drop it in as we're moving along. So bear with me. Alright, so we got the first section of code already plugged in. We've got all the libraries here. We dropped in pandas, matplotlib, numpy, seaborn. Go ahead and activate those. And got the data set downloaded. And go ahead and take a look at the first Now what this does is it allows you to take a look at the first 5 rows of data. And you can see that in the data you got the class, the alcohol content, the acid, and there's lots of other features in the data set. It just does the ... in the last several columns. Just gives you a quick overview of the data. Alright, once we've done that, we have taken a look at the data, and we can contrast and compare the measures for different types of wine samples. You can look at some stark differences in the attributes, and we'll emphasize that in the visualizations because just looking at the numbers doesn't do a whole lot. So what we're going to do first is what we call univariate analysis. Now, univariate simply means one dimension, and one of the quickest and most effective ways to look at one-dimensional data is to perform histograms. So what I'll do is take some histograms of the data here. I'm going to go ahead and drop the code in for that, which is here. And I'll open up the plots. Let's see if I can make it a little bit easier for you to see. Zoom in just a little bit there. Alright, you should be able to see all the histograms. This is the different attributes that are lined up. You can see the alkalinity, the alcohol level, the ash, class, color density. This just gives you a layout of how the different attributes are dispersed, whether it's a normal distribution or whether it's skewed in some way. In other words, you can see the different classes of wines, which is the X value. In the malic acid, for example, there's a strong skew toward class, looks like 1. And what's another example? In this data here, it's pretty normally distributed, except for in class 3, looks like the whatever the 315 of diluted wine, that's pretty strong there. But everything else, pretty normal distribution. So we can use the plots to get a good idea of distribution. And what else can we do? We can go to, we can drill down to visualizations of the continuous numeric attributes. Histograms, density plots work well. We can understand how data is distributed with density plots. So let me, let's do something in that area. I'm going to go down to the density plots to give you a good visual of that. That didn't work as well, did it? Let me go back. Next plot figure, 64. For some reason, it's not showing up on that part, so we'll move on to the next part. We'll visualize a discrete categorical attribute. Let's just take a look at wine quality frequency. Let's try that. For some reason the color didn't show up on that one. Okay. Now wine quality frequency is not showing up. This is so weird. Keyword quality. It's giving me an error message. Give me just a minute to troubleshoot this code. Looks like there's a traceback. Key error quality. Let me go back. Somewhere we've missed something. Okay. Don't you love when you work with something 10 times and it works fine until you go to show it to someone and then it doesn't want to behave? Welcome to my life. Okay, here we go. Let's try this. Okay, so we've got that one to work. Now let's try still isn't showing that. What is going on here? So if it's okay, I'm going to pause this real quick while I try to figure out why this is not showing up. So give me just 1 minute. It helps when you have your data set lined up with the code. I had the column name mixed up. I was trying to do sulfates, and sulfates didn't exist in this data set. The wine data set, there are like 4 or 5 different versions, and the one I downloaded didn't have sulfate as a column feature, so I was trying to analyze something that was not there. So yeah, troubleshooting code is part of the task that we get good at in our job. But anyway, now what we're looking at is color quality and alcohol content, that kind of thing. So taking a look at color intensity in wine, you can see the distribution here. And we can also go and take a look at the color density. Same information, just expressed differently. Color intensity here as a histogram, as a density plot. And this is another example of what you can do with the same data expressed with a different type of figure. So whenever you're determining the audience and the point of the discussion, always consider that. You have different options, different kinds of visual expressions, and that's part of the grammar of graphics that we're interested in presenting. All right, so another thing that we can do is we can take the analysis a little bit further, and we can do discrete categorical data attributes, and we can do bar plots and pie charts. Let's see, we can do multivariate analysis. Let's visualize data in 2 dimensions. And we'll try to do a pairwise correlation matrix depicted as a heat map. And let's see, I think we can take that information, drop it in our wine attributes, and import them into the code here. Okay, so hopefully you can get a good sense of that. And kind of hard to read here. Let me see if I can get it to zoom in a little bit. I'm going to remove my image here and zoom this in. Get a better visual. Alright, so you can see on this heat map, we've got attributes, class, and density, heat, all these different figures. And as the numbers approach correlation, they turn closer to red. Blue is cold, red is getting warmer. So the redder the numbers are, the more correlated. That's why there's a perfect diagonal line. That's because if you look at the attribute on the y-axis and on the x-axis, it's the same word. So if you look at the class of the wine, class, and class, that's the same word. So of course an attribute is 100% related to itself. What we do with these is we can verify that there is some correlation between two attributes in a data set. And data analysts use this to provide evidence of causality. Now, it doesn't prove causality because we don't know that one attribute is the one that caused the other, but all we can do is prove that they are related for sure, and that can add to more questions in your investigation. So remember that a heat map is really good for determining causality in a data set when you're doing multivariate analysis. So this is a really good, another visual expression. This is probably another way of saying that causality is evidenced just like you would do with a scatter plot. Sometimes you can do the same thing with a scatter plot diagram, because scatter plots do the same thing. They have a y-axis and an x-axis, and wherever the data falls, if they're related, they'll come close together. So, but a heat map is a little bit better for that. All right. So another thing we can do is look at pairwise scatter plots for multiple dimensions at the same time. So we can look at various columns. We can pick them. Let's see. There's columns: alcohol, ash, alkalinity, color intensity, hue. Let me see what we can do here. I'm going to have to adjust the code a little bit. I'm going to go ahead and copy the original code, drop it into Spider. Now, if you haven't worked with Spider before, this is a really good IDE. It's a front end for Python. What's happening in Spider is on the bottom right is the actual environment where the code takes place. On the left is the editor. You can actually go over here and write what you want to work with. So we can go down here, clear this up a little bit, scroll up, and I'm going to paste the code. Now that doesn't affect anything that's happening right now in the environment. What we're going to do is I'm going to go through these column names and I'm going to adjust them to match the actual data set. So the data set I've got working with has alcohol. Sorry, here where it says density, I'm going to change that to alcohol. And where it says residual sugar, I'm going to change that to malic acid. Sulfur dioxide, let's change that to the alkalinity. And what else we've got? Fixed acidity, I'll change that to the non-flavonoid phenols, just to have the same number of features. And this will set up our pairwise plots. Let's go ahead and copy this drop that into our editor. I mean our alkalinity of ash not in index. Ash. Let's try this again. Okay. Now let me drop it up to where you're zoomed in here. Hopefully you can get a good visual. It's kind of blurry, but you can see the pairwise plots. You can see all the scatter plots, density plots, and the different attributes labeled in just a few lines of code. So matplotlib in Python is a really good library to get familiar with. And this lines up your attributes to show you what is related. If there's a strong correlation, that means they're grouped together. Like malic acid here has a strong density that's skewed to the left, and there's a good visual representation there with a density plot. Alcohol content is pretty evenly distributed, as you can see. So multiple ways of expressing the same data. All right, what else can we do? We can move on to take a look at some parallel coordinates. Now, this is not my favorite, but it can help you spot outliers. So let's take a look at a parallel diagram. There are some diagrams that I like more than others. This is one of my lesser favorites. And I'll show you why in just a second here. It gives you a lot of information in a really densely packed image, usually. And sometimes it's information overload. So be cognizant of that and understand that some visuals work better for your information than others. But sometimes it's appropriate. So let's take a look. Maybe it'll actually work well. Key error wine type. Wine type file. Okay, so something wasn't. Coordinates wine type. Okay. To class. I need to change that to class. All right, let's try it again. I didn't like that either. EOL while scanning string literal, something in the way was. Let's try. 1. Helps if you have all the right quotes in place. There we go. Okay. Let's take a look at that zoomed in. So you can see alcohol, malic acid, alkalinity, and non-flavonoid phenols, and how they're related in a pairwise plot. In a parallel plot, you're supposed to be able to note the density and how they are related. And it's not the clearest chart ever, but you can see how 1, which is here, is strongly skewed toward 1 and 2, from 0 to 2, and 2 is kind of grouped in there as well, so 1 to 2 are kind of related. So they're kind of mixed together, and you can see how there's some strong correlation, but it's not the clearest because it doesn't tell us which one is 1, and 1 and 3 look like the same color. So that's not the best chart. Again, I don't care for parallel charts. We're just trying to show you different options available to communicate these things. We can also do, we've already done scatter plots. Let's take a look at, let's see if we can do a couple of charts and then mix them together. We're going to take a look at let's see if this one will work. Wine quality. To fix the indents. Part of the problem of borrowing code from the internet is that you inherit the mistakes written by people and you have to figure out what they did. So in addition to my own mistakes, I got to figure out the other person's mistakes. All right, so no, quality frequency. Let's see here. Let's see if this will work. We'll copy this and drop it in. No, it's not working. Okay. Well, at any rate, we've seen multiple charts from the same data, and the point is that with basic data sets, you can express different views depending on what features you want to look at and what specific points you're trying to make. And with the different views and different aspects of data analysis and data visual representation, it's important to understand the implications. The implications are that you can present your views from many different angles. And so the important thing to do when expressing any kind of analysis to an audience is ensure that you're remaining 100% objective. Okay? It's easy to see with the data set that I just showed you, and we just got into the surface really of what all you can do with multi-dimensional analysis. that you can make it say whatever you want it to say almost if you're not careful. So ensure that your scales are always the same, that the data is always completely fit in a way that it's not skewed, and that you're 100% objective in expressing yourself. So keep that in mind whenever you are building your graphics. Keep in mind the grammar of graphics. You always want it to be clean, concise, clear, and you want to try multiple image types to see which one communicates your message the best. Remember your audience, remember how well versed they are, and what the point is of the study, depending on what your questions are that you're answering. Because the more you uncover, the more questions you tend to ask from that. And so it can become really interesting. It can go pretty far down the rabbit hole depending on what you're looking at. But anyway, I hope you found that interesting and a good introduction to visual analysis and visual communication, because I always like to say that in data analysis and in big data handling, that it's both a science and an art. And as you can see, it takes some work and some reworking and troubleshooting sometimes. And technology sometimes can fail you a little bit. You can do something 10 times or 100 times, and then when you go to present, something just throws a monkey wrench in it. But if you can think on your feet a little bit, that always helps. It always helps to be flexible, and part of the skill of what we do is just rolling with the flow and troubleshooting. And I hope that that was a good lesson as well. So that's about it for now. If you guys shoot me any questions that you have, and if you want to provide a keyword for me, let's use the keyword wine quality, and that will let me know that you saw this. And I hope that this has been good for you. You guys shoot me any questions, any suggestions you have, any requests for an analysis, or anything you want to see at all, and we'll see what we can do. So you guys take care, and we'll see you in another week. Or let's see, no, we'll see you in a couple days actually. Take care. All right, Dr. Dax out.